Hi, Saintsman. We are starting lesson 8.2, which is proving triangle similarity through uh, AA, which is angle angle. Goodness. I have to move this guy real quick so you guys can actually see what I'm doing there. So through angle, oops. Oh, it keeps on snapping back to there. Nonetheless, here we go. AA similarity. What is that? AA, and we're going to talk about just triangle similarity because this is what we're going to be um, narrowing our focus to with regard to this course. With regard to geometry, specifically, we're going to start to look at the figure that is just a triangle, um, or that the polygon is a triangle, because that's going to branch into a whole another study of mathematics called trigonometry, which is going to be our next chapter. Now, we already started discussing congruence just between triangles, and there's now this notion of similarity, which is just the proportionality with two triangles. So, if we take two angles of one triangle and they are congruent to two angles of another triangle, then the triangles are similar. We don't need to prove all sets of the angles similar. Now, here's the thing that we notice, and let me adjust my software here to auto shapes. Help me out because as you guys know, oops, my drawings are not that great. So I have proportional figures, and what the similarity with the software, it's able to enlarge this proportionally, where we have I have these triangles A, B, C, and then this other one D, E, F. Okay, and then I have marked here A congruent to D and B congruent to E. Well, now remember we needed when we had um, similar figures, which was that all the angles would be congruent and all the sides would be mathematically proportional. And that's how we define similarity. Now, all the angles are going to be congruent because we don't need to prove the third angle. After the first two angles, the third one has to be congruent through the third angle theorem. All right? So, in other words, here, if angle A is congruent to angle D and angle B is congruent to angle E, then triangle ABC is going to be not congruent, but similar to triangle DEF. And if we don't know what that symbol means by now, you are not paying attention to these videos. Okay? Um, Continuing on. Let's go ahead and do an example from the book. The lesson should be kind of short today. All right. Take the outer shapes off for just a second. I have figure where X, Y, Z is one triangle, and RST is another. This guy is 21 degrees for angle X. Z is 99 degrees. T is 21 degrees. And R is 61 degrees. The question is, we have to determine if these triangles are similar. So how do we do that? Well, we know the interior angle sum for a triangle. Okay. Uh-oh. Is that craziness with me with the pen not working well? Okay, there we go. Then we know the interior angle sum of a triangle is 180 degrees. So we know that 21 plus 99 plus angle Z is going to be equal to 180. So we can take my sum here. 21 plus 99 is 120. That's angle Z. That's 180. Okay. So when I solve, subtract 120 from both sides, right? So angle Z is going to be equal to 60 degrees. Okay. And I think you guys, I'm sorry, not angle Z. That's angle Y. Goodness gracious. Keep on looking up this guy. That's angle Y. Let me fix that. So I'm going to pencil this guy in blue. This guy's going to be 60 up here. And then up here, this guy's 21. And then we, knowing that these guys, well, that one's 61. All of them have to be congruent, right? Doesn't really matter because I don't have, no matter what I have, angle R already isn't equal. I don't have to do any more calculations to figure out what angle S is, right? Because angle R is not equal to 61 degrees, right? Nor is it equal to 99 degrees. I just need to look for two of the angles, okay? It would have to be, right? I don't have to sit here and figure out what angle S is. 60, angle Y, or R has to be either one of these because I have the matching 21 and 21 right here, okay? So this is angle Y or angle Z. Okay, so therefore, the three dots, we can make our conclusion that triangle XYZ and triangle RST are not similar. There's only one set of angles matched. All right. So, new thing. And we're going to start to work with altitudes. And this is a unique thing that we're going to have here with regard to altitudes within a right triangle. Okay. So let me take my little Snap 2 auto shape feature. Right triangle. Okay. I'm going to take an altitude within that right triangle. And here's what I got. I have P, R, Q, and T. PT is an altitude. So we're going to show that triangle QPR and triangle QPT, QTP are similar. So I need the similarity in between the two of them. So here's what we have. PT is an altitude. And this altitude is always going to create three similar triangles, actually. And here's how we're going to have this guy. First of all, we have angle Q is going to be congruent to itself reflexively, right? This guy in this corner, all right? So that's one set of angles. Moreover, we have angle QPT. Sorry, QTP. Is going to be congruent with angle QPR. And that's because all right angles are congruent. So we're set. We're already done. Now we have to have the corresponding parts correct, right? We have triangle QPR is going to be similar to triangle Q, right? Because the Q's are reflexively congruent, and in QTP. So let me sketch this guy out. QPR, right? Q to P to R is Q to T to P. And this is through angle. Okay? And that shows that anytime you have an altitude of a right triangle, you have not two, but we have three. This guy's going to be similar. Moreover, you could do the same exercise using angle R. And this, of course, is going to be a right angle as well. This is your right angle. And then you have angle R reflexively, right? For both of these triangles, this guy and this guy. Excuse me. With also, and if this triangle, who's the big guy, is similar to both these smaller two triangles, this one and this one, they will also be similar to each other reflexively. All right. Last thing for today. Sorry, two more. Got a proof for us. All right. I think we're excited to do a proof. All right. F R S T U and V. And all we're going to be given is that RS is parallel to TU. Excuse me. Okay. So RS is parallel to TU, which we'll mark here. Uh-oh, my pen is malfunctioning again. There we go. What we will prove is that we have two similar triangles. Triangle SVR will be similar to triangle UVT. Now, we only have one way to prove similar triangles, and that's through angle-angle. So we already know what our last step has to be. Excuse me, what our last reason has to be. So we have our statements, we have our reasons. Okay? One, of course, we're going to restate that RS is parallel to TU, and that's given. Okay? Now, since that's the case, we need two sets of angles that are going to be congruent. Now, let's do this one, RSV, right? And TUV, this guy and this guy, which have to be congruent. And remember why. These are alternate interior angles. So that's great. I have one set. I need two sets. And of course, right here, these guys, which are adjacent, are going to be congruent. Or vertical, that is. Angle SVR. Congruent to TVU. And we're there. We've already done it, right? So we have triangle SVR is similar to triangle UVT. Okay, and it has to be S to V, right? 1 to 2. And then this is the third one, SVR. And then 1 is U, 2 arc marks is V. And then T is the unmarked one, and this will be through angle-angle. Okay, so we have the correct corresponding parts listed. That's it. This one can prove 2. All 3 are going to be congruent, and the third set is proportional. Last thing is regarding a cool scientific phenomenon. I'll actually discuss Eratosthenes when we get to class. One of the cool things he did with regard to the circumference of the Earth. So Mr. Granados' shadow. Talked about Eratosthenes and his slave. Mr. Granados is 3 feet. His shadow is 3 feet tall. And Mr. Granados get this format correctly. And he is 6 feet tall. The flagpole at Saints has a 17-foot shadow. So how tall is the flagpole? Now, here's what's kind of cool is that I may have a measuring tape that can measure, right? Because we can't climb that flagpole. It's super tall. And we know that we can take a measuring tape, measure Mr. Granato's shadow, measure him. You don't need to because I'm clearly 6 feet tall. I think some students in the past were arguing that if I'm not really that tall, perhaps only 5'11", which is not true. 6 feet. And here's actually how this would work. We can actually determine the length of that flagpole just based upon measurements of shadows, and here's why. If you take Mr. Granados right here, right? We'll draw very advanced drawing, Mr. Granados. Okay. Which you guys can tell the stick figure here has the same haircut and the same general smile. Right here, we're going to take the rays of this sun, right? Very bright. And it has rays here. The rays of the sun. It's going to create this, as Mr. Granados is going to obscure here, which is this shadow, which is right here. And this guy's 3 feet. And again, Mr. Granados is very clearly 6 feet tall. But then we have this flagpole, right? Which I'm not sure really how tall it is, but the same rays of the sun are hitting it and creating again, right? It's proportional shadow, and this is how we know the shadow is proportional, is because this guy's going to be 17 feet tall. Both are vertical and have a right. Oops. Oh, good. No. Have this right angle, right? And then, moreover, whatever angle the sun is creating these rays to obscure sunlight from the ground, which I've highlighted here and here, it's going to be exactly the same. So these angles are going to be the same. So these are similar triangles effectively, right? You can say that those two angles up there are congruent through angle. So if these triangles are similar, then we have a proportion, which would be 6:3 is the same as whatever this height is of the flagpole, x to 17. Okay? And we take a cross product, right? Which we did in class. And this is now easy, right? 17 times 6 is an easy problem. Because, of course, you guys know that your calculator makes it very easy, right? And you are a master of the machine. 6 times 17 is 102, and it's divisible by 3. 1 plus 0 plus 2 is, divisible by 3. But the machine actually does this pretty easily. Oops. Divide both sides by 3, and 1 and 2 divided by 3 is 34. Okay, so this is 34 feet. Oh, that proportionality, pretty cool. Saintfin, I will see you in class. If you have any questions, CV during office hours.